Okay, class, in this lesson, I'm going to introduce to you the various types of triangles, and it's going to be based on the types of angles that you learn. So before we do that, let's just review a couple terminologies. If you recall, angles that are less than 90 degrees are called acute angles. Okay, and then angles that are greater than 90 degrees are called obtuse angles. Okay, and then lastly, angles that are equal to 90 degrees are called right angles. Okay, so now that we're familiar with these terms, acute, obtuse, and right, we can apply these to triangles. Now, obviously, triangles are three-sided figures, hence the word tri, T-R-I, or the prefix tri meaning three, and then angles, okay, triangles. Okay, so now we can apply the three words that we mentioned earlier, acute, obtuse, and right, and apply those to triangles. So we can have an acute triangle, which means that all three angles are less than 90 degrees. Okay, so here's an example of a triangle or an acute triangle. So we got three sides here, and all three angles are less than 90 degrees. We have 70 degrees here, 50 degrees here, 60 degrees there. Okay, and then the next triangle is called an obtuse triangle, and let's go ahead and define that. Here, an obtuse triangle is a triangle where one of the angles is greater than 90 degrees. So let's draw one and see what this looks like. Okay, so here we have a triangle where this angle is 120 degrees. So it's greater than 90, and then the other two are less than 90. And then the next type of triangle is called a right triangle, and as you can guess, a right triangle has a right angle or an angle that's equal to 90 degrees. Okay, so here's an example where the triangle has a 90-degree angle over here, and then the other two angles are 40 and 50. Okay, so I'm going to pause here for just a second and make a note that if you take a look at the triangle angles, okay, so you have a 90, 40, and a 50. You notice that this adds up to 180, right? 90 plus 40 plus 50, which is 90, gives you 180, okay? And look at this triangle, the obtuse triangle. We have 120 plus 25, which is 145, plus 35 is 180. Notice that all of the angles here add up to 180. This adds up to 180. And let's go back to the acute triangle. 50 plus 60 plus 70 is also equal to 180. So one of the things that we can conclude is that every triangle, when you add up all three angles, they always add up to 180 degrees. Okay, just a side note, and make sure that you are aware of that. Okay, so let's go back to the right triangle. I wanted to point out a couple terminologies here. The first is that the side opposite the right angle, so here's a right angle, so the side opposite the right angle, so this side is called the hypotenuse. Okay, and then the other two sides, so the remaining side that are adjacent to this 90-degree angle are called the legs. Okay, there we have it. Now, there are two more triangles that I need to introduce to you in this lesson. The first one is called an equilateral triangle. Okay, so an equilateral triangle is a triangle where all three sides are equal. It would look like this. Okay, and again, all three sides are equal, so this length is x. This length is also the same, which is x, and this length is also the same, which is x. And the other unique thing about an equilateral triangle is that all three angles are the same. Now, what angle do you think that would be if all triangles have a total of 180 degrees? If you guess 60, then you are correct. So all three angles would have 60 degrees. Okay, and then the last type of triangle is called an isosceles triangle. Okay, and an isosceles triangle is a triangle where two sides are equal, and it would look like this. Okay, so here's an example where this side of the triangle has a length of x, this side of the triangle has the same length, which is also x, and then the base, or the third side, has a length of y. Okay, so let's go through a couple examples so you have an idea of what type of problems you will encounter. Let's go ahead and start with an equilateral triangle. Okay, so here we have an equilateral triangle, so all three sides are the same, and one side is expressed as 4x minus 25, the second side x plus 14, and then the third side 6x minus 51. Okay. So the goal here is to find the length of each side. Well, we know that in equilateral triangle, all three sides are equal. Okay, that means that we can set one expression equal to another, and it doesn't matter which one. So let's go ahead and select these two sides. Okay, so what we get is 4x minus 25 is going to be equal to x plus 14. Okay, so this side, which is expressed here, is equal to this side, which is expressed here. Okay, once we have the equation set up, then we can solve for x. First, I'm going to move this x to the other side, so I'm going to subtract x from both sides, and we get 3x minus 25 is equal to 14. Okay? Now, in case you don't know how we did that, I'm going to make a notation and say that we subtracted x here, and then we subtracted x here. Okay? So obviously 4x minus x is 3x, x minus x is 0. Okay. Now, we want to isolate 3x on this side, and so to do that we have to move this negative 25 over to the other side. And to do so, we have to add 25 to both sides. Okay? So, if we add 25 to both sides, we get 3x equals 39. Okay? The negative 25 and the positive 25 cancel each other out. And now we have 3x is equal to 39. To solve for x, we divide both sides by 3. And we get x is equal to 13. Now that we know what x is, we can plug this value into any one of these expressions. So let's plug the x, or the 13, into this expression. Okay? So if we know that this side is x plus 14, okay, then plugging 13 in there, we get 13 plus 14 is equal to 27. Okay, so the sides of this equilateral triangle is 27. Now if you want to test it out, we can plug 13 into this expression as well as this expression, and you will get the same number. Okay, let's try that out. So we're going to use this side, 4x minus 25. 4x minus 25. And we're going to plug 13 in for x. So 4 times 13 minus 25 is the same as 52 minus 25, which is equal to 27. Okay. And then lastly, we're going to plug the x into 6x minus 51. And so we get 6x minus 51. We're going to plug the 13 in for x, and we get 6 times 13 minus 51. 6 times 13 is 78. Minus 51 is equal to 27. Okay, so as you can see, all three sides work out. Okay, so let's solve another problem involving an isosceles triangle. Okay, so here is an isosceles triangle, WXY, triangle WXY, and we see that side WX, which is right here, is congruent, okay, or equivalent to XY. Okay, so these two sides are equal to each other. Okay, so let's find the length of all three sides. So the first thing we want to do is take advantage of the fact that this is an isosceles triangle. So these two sides are equal, which means we're going to set this expression equal to this expression. Okay, so we have 6x minus 77 is equal to 3x plus 4. We're going to solve for x, and then once we have the x value, we can substitute that value into each of these x's to solve for the length of each side of the triangle. Okay, so in solving this algebra, we're going to move this 3x over to this side, and we do that by subtracting 3x from both sides. Minus 3x, minus 3x, and now we get 3x minus 77 is equal to 4. Okay, now we're going to move this negative 77 over to the other side, and we do that by adding 77 to both sides. So we add 77, that's 77, and we get 3x is equal to 81. Okay, then to solve for x, we divide both sides by 3, and we get x is equal to 27. Now that we know x is equal to 27, we can solve for one of the sides. And let's start with 6x minus 77. Let's substitute 27 in for x, and we get 6 times 27 minus 77. And 6 times 27 is equal to 162 minus 77. And 162 minus 77 is equal to 85. Okay, so now that we know that this side is equal to 85, we automatically know that this side is equal to 85. Okay, let's go ahead and label that. This is 85, this is 85, and now all we need to do is solve for this third side. So we're going to plug in 27 in for x. Okay, so let's write this over here. 5x minus 31. We're going to substitute 27 in for x, and then we're going to solve for this. 5 times 27 is 5 to 335 minus 31, and that is equal to 104. Okay, so now that we know that this third side here is 104. Okay, I hope this made sense to you. If any of this was confusing, please go back to the beginning of the recording and listen to this again. Thank you.